So we've talked a lot about circles. Yeah, I know the hat's kind of funny. It's silly hat day for me. How about that? So we talked about a lot about circles. We've talked about how we can find the equations of circles. We talked about how we can find the equations of circles even when it's not written in that center radius form. We talked about how we can tell if a line is a secant line or a tangent line or neither of those, just a random line out in the middle of nowhere. What we want to do now is see if we can get the equations of those tangent lines. With a secant line, it doesn't matter because you got 2 points on a secant line. You can just get the equation from 2 points. But with the tangent line, because it only touches at 1 point, makes it a little more difficult to get the equation. So we want to look at a way to get the equation of that tangent line. So first, let's review some facts that we know about tangent lines, okay? So going to our lesson here. So this is our little do now information, okay? First of all, a tangent line and a radius are what? So hopefully you chose the choice that said a tangent line and a radius are perpendicular. Okay. What about the slopes of parallel lines? What do you know about them? Hopefully you said, oh yeah, I remember slopes of parallel lines. Slopes of parallel lines are equal. Okay. Two parallel lines have the same slopes. What about slopes of perpendicular lines? Okay, so perpendicular lines are opposite reciprocals. Remember, that does two things. The term opposite means that we're changing the sign. So if my slope was positive, the new slope is negative. If my original slope was negative, the new slope is positive. That's the opposite. Reciprocal means you flip the fraction. So an example of this, if I had a slope of a line that was 2/3, then the slope of the perpendicular line would be negative, there's the opposite, 3/2. That's the reciprocal. Okay, so that's how that works out. So that is something we talked about earlier in the year with the equations of lines. What about the slope-intercept form of a line? Which of these is the slope-intercept form? So remember, the slope-intercept form requires you to have two things, a slope and a y-intercept. So it's a form that you know best as y equals mx plus b, because in that form, m is the slope and this b is the y variable for the y-intercept, which will be at 0, whatever b is, okay? Of course, that form was what you learned in algebra. This year, we also learned another form of a line. We learned a point slope form. So which of these is the point slope form of a line? So point slope form, you realize, uses a point and a slope. So that's the one that was y minus y1 equals m x minus x1, okay? And in this case, the slope is the m, okay? There's my, let's write the word slope here. That is the slope. The point that we use is the point x1, y1. So that makes the point for the point slope form. We're going to need all of this information, remembering what we did about lines, so that we can actually do this and figure out equations of lines dealing with the circle. So we actually know all the information we need. Let's look at an example of finding the equation of a line that is tangent to a circle. Okay, so I'm going to graph this just so we can see an example of it. You don't have to graph these, but just so we can see an example of what's going on. Remember my circle, my center of my circle is, okay, so hopefully you remembered center of the circle is 4, 5. The radius is going to be the square root of 20. And for the sake of this, that I can graph my circle, I know that the square root of 20 is approximately 4.47. I need to get a decimal there because I don't have square root of 20 on my graph. So when I go to graph that, that's 4, 5. There's my center. I'll call that my center there. And in 4.47, that's about 4.5. So I'll count over 1, 2, 3, 4 and a half-ish. 1, 2, 3, 4 and a half-ish. 1, 2, 3, 4 and a half-ish. And then we're going to come back 1, 2, 3, 4 and a half-ish. And I've also got this point 8, 3. So while I'm at it, I'm going to graph this point 8, 3. So that's at 8, 3. That's going to be there. Now, that point's going to be on the circle because that's where the tangent line touches the circle. So that helps me draw my circle a little better. Sketching my circle, it's going to go through all of those points. Hey, pretend that's a circle, even though it looks like a rounded square. But hey, we're going to deal with it. It's a sketch. We've also got the line. Now, what is the line? The line is going to touch the circle at just that point. And that's the line I'm trying to get the equation of. I want to know what the equation of that line is. Well, remember, we do have another piece of information here. We have this little segment there. Remember, that segment is my radius. And we said that if I have a line that's tangent, well, a tangent line is perpendicular to the radius. So if I can get the slope of the radius, I can get the slope of the tangent line. So let's start with the slope of the radius. I'll use a little sub r there to show that that's the radius. Slope formula, remember, y2 minus y1 over x2 minus x1. So my y2, the 2 points I'm going to use are my center, because that's the center point here, and this point there, because that's that point. Okay, so those 2 points are the ones I'm going to use for my slope of the radius. So that's 3 minus 5 over 8 minus 4. So that gives me a negative 2 over 4, and we always simplify our fractions, negative 1/2. That's the slope of the radius. Notice I'm labeling everything, okay? I don't want to just say m because I'm going to have a lot of slopes here, because that slope is not the one I want to use. I want to use, that's the slope of the blue line here, okay? So that's the slope of this line, but that's not the slope I want. I want the slope of this line. So to get that line, I have to go, wait a minute. I need the slope of the perpendicular line. So opposite reciprocal, it was negative, now it's positive. Reciprocal of 1/2 is 2 over 1, or just 2. So now I have the slope of the red line. Okay, what else do I have for the red line? Well, I'm going to go back to my highlighters here. I've got a slope and I've got a point. So since I've got a slope and a point, maybe I'll use the point slope form of the line. Y minus y1 equals mx minus x1. So that's y minus 3. My slope is 2, x minus 8. And they didn't say put this in any particular form. So because I tend to make a lot of mistakes, which you guys have seen in some of these videos, I'm going to keep myself from making any algebra mistakes and leave it just like that. There's the equation of the line. Okay. So that's how these are done. You just need to calculate a few things to get this. I need to know the slope of my radius. Once I know that, I can get the slope of the line. Once I have a point and a slope, I can get my equation. Okay. So let's take a look at an example that you're going to go through, and we're going to go through it step by step here, okay? So here's your problem. What is the equation of this line tangent to this? Take it through and do each of these steps. Go for it. So you went through this. Hopefully you got y plus 6 equals 1, x minus 6. By the way, because of coefficient of 1, you don't have to write. You could write this as just x minus 6. You could even leave off the parentheses in that case because there's no need for them. Or you could write it, I move my 6 to the other side, and I write it like that. So any of these are appropriate answers for this, okay? So let's look at our next problem then. This one asks 2 different questions. So the 2 questions that it's asking, first of all, what is the equation of the circle? So let's start there. Let's get the equation of the circle. To get an equation of the circle, I need 2 things. What do I need? Okay, so I need the center, which was given to me, center of the circle, -3, 5. And I need the radius, which I don't know. Now remember, the radius by definition is 2 things. It's either the segment from the center to a point, or we could say it's the length of a segment. And length, another word for that, is distance. So I'm going to use my distance formula between 2 points, my center and a point on there. That's going to find the length of the radius, which is really what we're talking about when we say what is the radius. So that's 6 minus negative 3 squared plus 8 minus 5 squared. So I'm just using my distance formula, except I labeled it R instead of D. 6 plus 3 is 9. 8 minus 5 is 3. Still squaring it. 9 squared is 81. 3 squared is 9. So that's radius of square root of 90. Now, they didn't ask me for the exact radius. I'm going to leave it as square root of 90 because I already know what's coming up. Watch what happens when I leave this as square root of 90 and use it in my circle formula. Remember, my circle equation is x, let me write that so it's a little cleaner, is x minus h squared plus y minus k squared equals r squared. So that's x minus negative 3 squared, y minus 5 squared, that's my center, and in my radius, square root of 90 squared. But wait a minute, if you square the square root of 90, the square and square root cancel each other, leaving me with the number 90. So there is the equation of my circle. And you can see why I left it as square root of 90. Why take the square root, simplify it, when they weren't asking me what is the radius. If they'd asked me what the radius was, I'd have to give it in simplest form. But they weren't asking for the radius. So always make sure you know what the question's asking for. Okay, so that's part one, the equation of the circle. The next part of this question says, what's the equation of the line tangent to the circle at D? So here, to get the equation of the line tangent, I need, first of all, slope of the radius. So let's start there. Slope of the radius. So that's between the 2 points, C and D. So I'm going to use those 2 points to get my slope. 8 minus 5, 6 minus negative 3. 8 minus 5 is 3. 6 and 3 is 9, which gives me a slope of 1/3. Slope of the radius. Again, I always write that to make sure that I know which slope I'm dealing with. Once I have that, well, now I just need the slope of the tangent line, which is easy. This is negative or positive 1/3, so now it's negative, and reciprocal of 1/3 is 3. So now that I've got that, I'm all set to finish off this problem. So my line is now y minus, using point D, 8 equals negative 3 x minus 6. And did they ask me to put it in any particular form? No. So I'm not going to risk myself making mistakes. I'm going to leave it just like that. And there we go. There's our equation of a tangent line. So now it's your turn. Same type of problem. Try that. And again, I'm taking you through step by step. So start with the equation of the circle. Okay, so you got your equation of the circle, just to go through and double check all the pieces. Center, that was given to me. Radius, I used my distance formula, and I got down here to where it said square root of 164, and I said, hey, I don't really need to know the radius, so I can leave that. What I need to do is put it into my equation. Little things to watch out for, the squareds. By the way, some of you have been typing SQRT. SQRT is square root. That's this thing. Okay, squaring and square rooting are not the same. So this is squared. You could raise it to the second power. Okay, so there's the equation of the circle. That took care of part one of this problem. Part two, what is the equation of the line tangent at point, oh, I should say point B. So change that, at point B. Okay, go for it, step by step. Okay, so it took you through that. You found the radius, the slope of your radius first, and you should have gotten negative 4/5 for the slope of the radius. Again, I labeled all that, kept my equal signs lined up, so all nice and neat, easy to follow. But that's not the slope I want. I want the slope of the perpendicular. So that's 5/4. And I can take that and enter it into my equation using the point B there as my point. Okay, so that's all we've got. Okay, not that bad a lesson. Follow through those steps, you can do this. Okay, so you've got a Google form to work on now, and that's pretty much the end of this unit. We'll do some practice stuff, and then we'll see how you did through this. Have a good night.